Hello everyone! I hope this video finds you well, and that you are ready to handle your last round of final exams with confidence and gusto. While I'm excited for you to start the next chapter of your lives, it makes me sad to think of this as our last field trip together. But since you probably have a decent handle on the lab and field techniques that we would do in this course, let's make some coronavirus lemonade. I'd like to take you someplace special. Someplace new, someplace that we can't usually afford to take classes, but which I can visit, because I'm working remotely and I know people. Someplace that you would have to set aside at least an entire day to visit. Let's go to San Juan Island. The San Juan Island archipelago is an awesome spot. I think we could easily spend an entire year talking about the climate and microclimates, ecosystem, and remarkable biodiversity created by the literal habitat islands, not to mention the sensitive and unique species present, and the ways in which they're impacted by humans, climate change, history, and governmental policy. While some places in this area bear original Lushootseed names from Coast Salish peoples, and while there is a significant amount of influence from British and American governments, you will notice that a lot of the place names around sound Spanish. That is because the first Europeans to thoroughly explore the area were sent by the Spanish government of Mexico. Explorer Francisco de Eliza, sailing under the authority of the Viceroy of Mexico, Juan Vicente de Güemes Padilla Horcasitas y Aguayo, second Count of Revillagigedo, probably claims the most names in the area. San Juan Island is the second largest island in the archipelago and county that bears its name, but it is home to by far the largest population. The county seat, Friday Harbor, is the largest city in the islands. Some particularly interesting features pertaining to your class, which I would like to show you, are the lagoons near Cattle Point at the southern end of San Juan Island. If you find yourself near Griffin Bay, you will see three small lagoons, from north to south: Old Town Lagoon, Jakle's Lagoon, and Third Lagoon. Jakle's Lagoon in the center is the largest of the three. It is composed of two main sections, the larger western pool and the smaller eastern pool. A shallow channel connects the two, fluctuating between overflowing in the winter and bone dry in the summer. Right now it is springtime, and the channel is muddy, but without much standing water. Lagoons are formed when terrestrial sediments from streams and rivers interact with marine processes such as wind, currents, and waves. The sediments are thrown up in a berm, and water is trapped behind. Once formed, lagoons can be filled in by in-washed sediments and deposits, or eroded into bays by marine action. Which occurs is impacted by the rate of sediment supply and the relative sea level rise. Since lagoons are sensitive to the impacts of climate change, they are considered sentinel systems. Lagoons are highly complex ecotone ecosystems. Water quality and biodiversity can vary dramatically, even within the same lagoon. Lagoon water inputs are driven by evaporation and precipitation, groundwater input, surface runoff, and exchange with the ocean. This exchange is driven primarily by tides and wave action. The amount of freshwater and saltwater input impacts the salinity of the lagoon itself, and can change dramatically throughout seasons and even within a lagoon. While Griffin Bay looks calm enough today, the large numbers of beach logs that have been tossed up into the lagoon by winter storms tell the story of times when that peace has been spectacularly broken. However, any increase in salinity on a day like this would be from water evaporating out of the lagoon, or seawater seeping through the dividing berm. As for freshwater inputs, it's worth taking a step back to look at the greater geography of the region. The San Juan Islands are in the rain shadow of the Olympic Peninsula. As relatively warm, moisture-laden air from the Pacific Ocean travels up the Olympic mountain range, it condenses to dump an average of 100 to 140 inches of rain per year into the temperate rainforest. Air descending the leeward side of the Olympics to the Puget Sound has been stripped of much of its moisture. As a result, the northern end of San Juan Island receives an average of only 29 inches of rain per year. Here at the southern end of the island, the climate is drier yet, with an average of only 20 inches of rain per year. While it's still no desert, it's not uncommon to see thriving cacti while exploring the San Juan Islands. Stepping back to Jakle's Lagoon, you can hike around the perimeter without finding a single stream flowing into it. However, if you look to the west, you will note that a ridge divides the southern tip of the island, and this lagoon sits neatly in a bowl within that ridge. The lagoon is fed by runoff water collected in that bowl, seeping through soil or flowing over the surface of the ground during rainfall events, and ending up in the lagoon. A small rocky extension of this bowl protrudes into Jakle's Lagoon, dividing the eastern and western pool. This also means that most of the runoff water first reaches the western pool before flowing into the eastern pool. One major impact on the water quality of lagoons is their flushing rate. In other words, how long water entering the lagoon stays before exiting. In a lagoon with lower flushing rates, nutrients remain in the lagoon longer. This means that plants are less limited by nutrients, allowing high primary productivity and subsequent high secondary productivity. However, this riotous growth can also lead to eutrophication, hypoxia, and reduced biodiversity. While there are no streams feeding Jakle's Lagoon, a walk on the beach side will show that there are also no major channels draining the lagoon. There are a few freshwater seeps along the beach, but no rapid flow, at least not this time of year. This makes it a little more difficult to measure the flushing rate, since you can't measure flow in the ingoing and outgoing channels as you would in a stream or river. Let's look at it anyway, and do what we can to investigate the water quality within the two pools at Jakle's Lagoon. Starting with inflow, it appears that most of the rainfall in the Jakle's Lagoon basin drains into the western pool. While I did not carry a boat into the pool to measure its maximum depth, I can confirm that it reaches well over the tops of my boots. The channel connecting the two pools is deepest where it comes out of the western pool, but narrows to a point where you could walk across it in the springtime wearing your least favorite street shoes without getting your socks wet. Enough water must be present to flow over this high point for it to enter the eastern pool in any large quantity. However, most water appears to exit these pools by seeping through the gravelly berm that separates them from the salt water. The eastern pool is much closer to the salt water, and any water exiting the lagoon has much less berm to filter through near the eastern pool than the western pool. Salinity is a common way to classify lagoons. Water that is oligohaline will have a salinity of 0.5 to 5 parts per thousand. Mesohaline water will be 5 to 18 parts per thousand. Polyhaline water will be 18 to 30 parts per thousand. Euhaline water is 30 to 35 or 40 parts per thousand, depending on which article you use for your definitions. Metahaline water is 40 to 65 parts per thousand, and anything above that is considered hyperhaline. The ocean itself is euhaline, varying from 31 to 38 parts per thousand. Measuring the western lagoon shows a salinity of about 30 parts per thousand. This lagoon is too shallow to measure with a Secchi disc, So we will do a quick and dirty turbidity estimate using a transparency tube. Transparency tubes were first developed in Australia for citizen science stream monitoring efforts. They consist of a clear tube just over 60 centimeters long, marked with a Secchi pattern at the bottom. Also at the bottom is a drainage tube with a shutoff valve. The side of the tube is marked in centimeters. The researcher should fill a clean tube with water and hold it under their eye. Drain water out of the tube until you can just barely see the Secchi pattern. Then read the water depth in the tube using the scale on the side. If you can see the Secchi pattern while the tube is full, the transparency measurement is recorded as greater than 60 centimeters. As with a standard Secchi disc, readings can be affected by light conditions and the eyesight of the person taking the reading. At the western pool, I also took dissolved oxygen readings. Since the height of my boots did not allow me to go beyond the thick mats of algae at the pool's edge, the reading was 10.67 milligrams per liter, or 115%, at 19.5 degrees Celsius. I also took a water sample for a simple analysis of the type you haven't done since your sophomore year. A plankton tow at the West Lagoon brought up lots of life, including plenty of copepods. This shot is at close range within a white plastic pan, and they are clearly very active. The salinity in the East Pool came to 27 parts per thousand, which surprised me. I had fully expected it to be higher than the Western Pool, as it appeared to have lower freshwater input. For comparison, the seawater in Griffin Bay on an incoming tide had a salinity of 33 parts per thousand. One possible solution is that at this time, this spring, there is more influence from freshwater runoff inputs from the hills than from saltwater seeping into the lagoon pools through the berm, or the salt concentrating through evaporation. Of course, this can easily change as winter storms overtop the berm, or as the summer brings dry weather. The eastern pool has a noticeably greener color than the western one. Likewise, the transparency in the western pool was 52.2 centimeters, whereas the transparency in the eastern pool was only 37.7 centimeters. The seawater outside had much greater transparency. It measured over 60 centimeters using the transparency tube, and white clamshells on the gray mud could easily be seen in over 10 feet of water. Once again, the height of my boots did not allow me to get past the algae mats at the pool's edge, though the eastern pool had even more vigorous growth. Our meter measured 13.43 milligrams per liter, or 151% dissolved oxygen at 21.7 degrees Celsius. A plankton tow was taken. Again, it did have numerous copepods. Had time permitted, it would have been very interesting to analyze the samples with a microscope to identify and quantify algae and smaller zooplankton for comparison. While measuring water quality, we noticed a small section at the edge of the eastern pool with shallow water completely devoid of algae. It did, however, have numerous small, thin tubes extending from the mud up to the surface. When deployed, the tubes shoot up from the bottom. When disturbed, they retreat rapidly. Are they worms? Sentient plants from outer space? Nope. They're rat-tailed maggots, a classic indicator of poor water quality. They are the larvae of syrphid flies, also called hoverflies. The tubes extend from their posteriors to the surface of the water and are used for breathing. You can easily identify them from the little dimple they make on the surface of the water due to surface tension. These breathing tubes allow rat-tailed maggots to live in utterly eutrophic, stagnant, oxygen-deprived water. In fact, our meter measured only 12% dissolved oxygen in their pool. These maggots can even live in cesspools and sewage lagoons. A quick water quality analysis was performed on the same YSI photometer that we typically use in 100 and 200 level classes. This meter was chosen instead of our accredited lab methods for multiple reasons. First, the data was used for curiosity only and not for publication, so the accuracy and precision of our accredited lab methods were unnecessary. Second, I was very far from the lab, with limited refrigeration and small sample bottles. Third, this meter is built so that it can be used outdoors in the field, as long as the light-blocking cap is installed over the cuvette, and we rarely take it outside, so this seemed like a good opportunity to test it. While no water sample was taken from the part of the eastern pool with the rat-tailed maggots, it was interesting to see that the eastern pool had a much higher ammonia level at 0.13 milligrams per liter than the western pool at 0.03 milligrams per liter. Likewise, it also had a much higher phosphate at 0.32 milligrams per liter compared to 0.02 milligrams per liter in the western pool. Had time and resources permitted, it would have been very interesting to compare water quality results for the section of the eastern pool with little life aside from rat-tailed maggots. You, or perhaps someone you may meet in the future, might say, "Great, a lagoon with maggots. Why do I care?" Well, lagoons have a lot of different kinds of value to us humans. Pragmatically speaking, they can directly impact our wallets. As lagoons more connected to the ocean than these small specimens at Griffin Bay are critical nursery grounds for commercially important fish species. Lagoons in developed areas also protect shorelines from costly damage during severe storms. Lagoons also have scholarly value to those who study them and do research there. Knowledge simply for the sake of knowledge is valued by many. However, this can also lead to commercial gain when it results in things like better informed management of commercial fisheries. Lagoons have inspirational value as a great place for photography and a subject and inspiration for paintings, films, literature, songs, and other forms of art. Don't overlook tacit value either. Unspoken things, like the sound of waves and shorebirds, the crunch of pickleweed under your feet, and the way that lagoons sometimes warm up sooner for swimming than the surrounding saltwater. These lagoons on San Juan Island are great for enjoying the plants and animals in the area. Here at Old Town Lagoon, just north of Jakle's Lagoon, birds are everywhere, even on a rainy day. Ducks are beginning to pair up, though they aren't yet settled down enough not to fly from errant hikers. This silver fox, a melanistic morph of the red fox, has even enjoyed stealing a slice of bread from human picnickers on the beach. While this site may look wild, humans do have a deep and even violent history in this place. Though originally used by Coast Salish peoples, Jakle's Lagoon is named for George Jakle, who owned a nearby farm along with his wife. Before farming, George Jakle was a soldier at the nearby American camp during the Pig War. If you aren't from Washington, you may not have heard of the Pig War between Great Britain and the United States of America. You see, when the Oregon Treaty of 1846 laid out the 49th parallel as the boundary between the Oregon Territory belonging to the U.S. and the Columbia District belonging to the British, the wording regarding the ownership of the San Juan Islands was vague. Wording said that the border would follow through the middle of the said channel to the Strait of Juan de Fuca, without saying which channel that was. Each country laid claim to the San Juan Islands. The British held that the dividing channel between the two countries was Rosario Strait, while the United States argued that the border was at Haro Strait. The first permanent non-native settlement on San Juan Island itself was established in 1853 by the British Hudson's Bay Company, which made a salmon curing station and a sheep farm. American settlers also came to the island, and soon San Juan Island was occupied by American, British, and native people simultaneously. Conflict can come to any community, and even more so when neighbors dispute each other's legal right to live there. On June 15th, 1859, an American settler named Lyman Cutler found a large black pig rooting in his garden, eating his potatoes. He shot and killed it. However, the pig belonged to a British citizen named Charles Griffin. British authorities threatened to arrest Cutler and evict the American settlers from the island. The American settlers sent for military help, and it arrived in the form of a company led by George Pickett, who would later go on to fame in the Civil War. The British quickly deployed 3 warships to the site with Royal Marines and engineers. The Americans likewise brought in reinforcements. Both sides settled in, and a 12-year joint occupation began, as politicians negotiated to resolve the dispute. The eventual sites of both military camps are now part of a national park and can be visited by tourists, and you can walk through the grounds of American camp surrounded by a white picket fence, or stroll through the formal garden at English camp. During the joint occupation, both sides interacted with one another peacefully. Officers attended church together, and both sides hosted dances and picnics to which the other side was invited. The American troops attended Victoria Day festivities held by the British, and the British attended Independence Day celebrations held by the Americans. In 1871, the question of ownership of the San Juan Islands was referred to Kaiser Wilhelm I of Germany for settlement. A team of 3 arbitrators was assigned to the issue, and they worked on it for almost a year before ruling in favor of the United States on October 21, 1872. By November 25th, the British troops had withdrawn from San Juan Island, and U.S. troops left in July 1874. In the end, the only death in the pig war was the pig. Thank you for joining me today. Once San Juan County has reopened to visitors, you can come see this beautiful place for yourself to experience the history, hiking, and nature. Bon voyage, class of 2020. It has been a pleasure and an honor to work with you. Good luck in all that you do. Stay in touch.